Hi there and welcome to this video for Senior Physics on Electromagnetism and Electricity. In this video we're going to use the PhET simulation to show how electricity can be generated from a change in the magnetic field. Now basically I've used the link which you can see shown on the screen here, but I've also posted this link on the iTunes U course so that you can download it and have a play. So let's just open up the link and start using it to see how we can generate electricity. So when you open up the link, you'll get this screen. Now it will be Faraday's lab, and I'll just open the screen for you there. So what you'll then see is a number of different types of situations which we can set up. We've got the bar magnet that we used earlier, pickup coil, electromagnet, and generator, and we'll be using the transformer in the next post. But for today, we're going to concentrate on the generator. Now obviously to produce or generate electricity, I'm going to need a magnetic field. Now the magnetic field is shown here by this magnet, which is linked to a water wheel. The water wheel will be driven by this tap here, where I can control the flow of the water using this dial at the top here. Now what's going to happen is, you can see you've got your north and your south pole. Now as that turns, we're going to get a change in magnetic field. That change in magnetic field will then be picked up by this electric wire. Now remember, as that magnetic field moves, it's as though this coil is moving as well, and this contains charged particles. And if the charges are moving relative to this magnetic field, then the result is I'm going to get a change in flux. Change in flux, according to Faraday, basically produces an EMF or a voltage. So let's start it up and see how it works. So you can see here that what I've got is my water moving, and instantaneously you can see that the light bulb is actually lit. You will also see that the electrons are oscillating between the north and the south. So they move basically dependent on where the poles of the magnet are going to be. Now remember that the density of the magnetic field is going to be greatest when you've got the pole where the arrow is now. It's going to be weakest down here, because remember, the density of those fields are going to change. So what's happening is, as we rotate our water wheel, we will see that we're getting a change in density of the magnetic field in this area here. This causes a change in flux on the electrons, and as a result, that change in flux on the electrons causes a force, an EMF, which pushes them in one direction and then in the opposite direction as it changes to the other pole. The result is that we generate a EMF. That EMF is then represented as a voltage which is applied across the light bulb, and the light bulb lights. Now obviously if I increase the flow, I increase the change in magnetic flux over time, which means I'm getting more of a voltage which will be generated. And you can see as I soup up the revolutions, you can see the amount of light that is generated is going to increase. Slow it down, and the opposite occurs. This is due to a change in EMF which is going to be generated. Okay, well what we can then do is say, well, let's put a basic, nice slow flow of water, and we'll keep the flow the same. And what we'll do here is we'll increase the number of loops. So you get the idea as to what has been generated in the light bulb. So let's increase and put another loop in. Now remember, putting another loop in means that any movement which is generated on the electrons increases. We're basically putting in a solenoid. So what we should see is, increasing with the number of loops increases the number of electrons which are subjected to that change in magnetic field, and as a result that's going to cause an increase in EMF. So we should see a brighter light which is generated. Now you can see that the lines have gone up. Do it again, and it's gone up even further. So we've got more electrons subjected to the same change in flux. As a result, I'm getting a larger EMF which is generated. Now we can actually have a look at this by using a meter, and we can see the oscillation as we go from north to south and back again. Okay, increase the number of loops, and we should see an increase in the movement of the arrow. Okay, so I hope that sort of makes sense. We could obviously increase the strength of the bar magnet, and if we increase the strength in the bar magnet, we should actually see a greater movement which is generated with our voltage, which is shown. We can put our fields in if we want as well, so we can see those change in those magnetic fields as they move. And remember, we're all talking about density here. Okay, so I hope that makes sense to you. Do go on to the site and see what happens when you change the speed, add more coils, and have a play with it. Very, very useful tool, but hopefully this illustrates the concepts which we want you to pick up in this sort of area. Well, thank you for watching, and join me again when we'll be looking at another concept in electromagnetism and electricity. Thanks for watching.